Hi everyone and welcome to PrepFusion. I'm Anish and today we will be starting the lecture 8 of state space chapter, right? So in the previous lecture we did like case 1 for the solution of the state space equations basically and the output equation where the input was 0. We are only finding the response for the state, right? Initial values. So basically we are finding the 0 input response. So in this lecture we'll continue the lecture. Basically we'll basically derive the properties of state transition matrix and the complete solution of state space, right? Complete solution of state space equations and the output equation basically with the input also this time. Okay, so yeah, let's start this lecture. So until now what we are solving when the input is 0, right? When the input is 0, we had our state variable like this, right? State equation like this. So our x dot t like our x of t equals to phi of t into x of 0, right? So what was my phi of t? This was my state transition matrix, right? State transition matrix. Now can I find the response? Finding the response is very simple, right? So this one is e raised to power at into x of 0, and also like what is my y of t? Y of t is simply c times x of t, right? Now what is x of t? X of t is c times phi of t into x of 0, okay? Or this is c times e raised to power a of t into x of 0, okay? This is also I can write. So all these things I can write, okay? And all these things are valid. All the equations are valid here. All the equations are valid here only when the initial conditions are at t equals to 0, okay? Only if conditions are at t equals 0, okay? Only if the initial conditions are at t equals to 0, okay? Now what if the initial conditions aren't at t equals to 0? Okay, then how we will find the response and the state variable basically. So initial conditions aren't at t equals to 0, right? Initial conditions aren't at t equals to 0, okay? Aren't at t equals to 0, then how will we find the response? So basically my response I will find with the help of state transitional matrix, okay, with a few properties, right? With okay, I am not able to write with the help of properties of state transition matrix, okay? With the help of properties of state transition matrix, okay? So that's why we will learn few properties of state transition matrix. So in short, right, I write state transition matrix as STM, okay? So yeah, what are the properties of state transition matrix? So properties of STM. So the first property, right, the first property is this one, that our phi of 0 like will be equals to identity matrix I n cross n, whatever is the order it, or whatever are the number of state variables, n is represent the number of state variables. So my phi of 0 will be equals to n cross n. So let's say if my like order is 2, right, order is 2, number of state variables are 2, then phi of 2 cross 2 will be equals to a 2 cross 2 identity matrix 0. Okay, 0, right. So this is my identity matrix. So now let's like proof, right, let's prove. Like I will not prove all the properties, but a few I'll prove, because proof is not that important anyways, but just to get a basic intuition, right, just to get a basic intuition, I will prove it to you. Okay, else proof is not that important. Like simple proof also you can do, like this one, that the simplest proof is this one. Okay, everyone does this. So what you do is, what is my phi of t equals to, actually it is e raised to power at, right. So he can assume it like a single element, and you can do like put t equals to 0, and what you get, e raised to power 0, right. So you get only 1. Okay, only 1. Okay, but 1 in matrix format represents I, so I will write I here. Okay, but this is just like a fake proof basically. So like the real proof, what is the real proof? So how can I write the e raised to power 80 as? So again, going back to that equation again, so e raised to power 80, right, again to diagonalization, I can write here like m e raised to power d of t into m inverse, right, m inverse. So again, let me expand this. This is m only. Okay, and this is, what is this again, right, it is like each values are raised to the exponential. So e raised to power lambda 1 t, e raised to power lambda 2 t, and this is keeping on going, right. And yeah, and what is this? This is m inverse. Okay, and other values are 0 only. Other values are 0 only. Okay, other values are 0 only. So yeah, this is how this is. So this is m inverse. So now here you put t equals to 0. Here you put t equals to 0. What do you get? You get 1 1 1. So this is only identity matrix, right? This is only a identity matrix. So this is I only. Okay, and this is m inverse, right? So I times anything is that matrix only. Okay, so again m inverse time m is I only. So what do I finally get? So e raised to power like phi of 0. This is okay, let me write it here. Phi of 0 basically equals to simply basically I, right, basically I, because this m and m inverse get cancelled and we are left with I. So this is the actual proof. Okay, so yeah, this was the first property. Let's now learn the second property. So what is the second property? Second property is the differentiation property. So basically, right, if I do phi dash of 0, okay, phi dash of 0, what will I be left with is only a, right, only a. Okay, phi dash of 0 will only be basically a. Wait, let me write it like this. It is basically a matrix only, my system matrix. Okay, so this I won't prove it to you, but the fake proof I can give again. Okay, like the intuition or the fake proof, whatever you want to call. Okay, the fake proof is like phi of t is what, e raised to power 80, right. So if I differentiate this, what do I get? Phi dash of t equals to a e raised to power 80. Okay, now you put t equals 0 here, so phi dash of 0 equals to a only. So this is the fake proof basically. So yeah, or like if you want to do again, you expand in that format and solve for it, you will understand. Like I don't want to make this lecture very long, okay, with proofs, because the main thing in gate examination, right, is to solve question. Obviously, like with few of the proofs that I like explained to you are important, because to understand the questions and all those things. Okay, like how to solve the question. So few of the proofs are important, but few of them are not. Like this one is not that important. Okay, so yeah, the third property. What is the third property? Third property, right? Third property is phi of like the power property. So if I raise the state transition matrix to the power k, my state transition matrix becomes scaled in time. Okay, if I raise it to the power k. So this one I will prove. Okay, So like what you can do is, again, the fake proof I will give. Okay, fake proof I will give. So e raised to the 5 of k to the power t, right? So what does this mean? This means that like what is it equals to? It is e raised to power at, right? So e raised to the power k, so again this becomes e raised to power kt, right? So my time is scaled, right? So e raised to power a kt. So what I can write this as 5 of kt, right? So yeah, so e raised to power at was 5t. Okay, if it is e raised to power k times t, a k times t, so this will become kt. Okay, so yeah, this is my basically state transition matrix. Okay, so like what is my example? Like let me take an example, right? So let's say I have 5 of cube, right? So what will it become? It will become 5 of 3t. Okay, so yeah, also this one is very important. Let's say I want to find the inverse of the state transition matrix, right? So what will it become? It will become simply 5 of minus t. Okay, 5 of minus t. So instead of t you replace minus t. Okay, so this one was the important concept in this, right? Important concept in this. So like if you want the real proof, okay, you do it for yourself, because we are constrained in time, right? So I won't go into the proof, because no one tells the proof. The important point is just you are able to solve the questions, okay, with the help of these properties. That is the more important point. Okay, another important property is the fourth property. So this is the transition property, right? State transition property. So let's say I have one state transition matrix which is going from t1 to t0, okay, and another transition matrix which is going from t0 to t2, okay, t0 to t2. Then the product of these two matrices, right, the product of these two matrices will be simply equals to t1 minus t2. Okay, I don't need to find the in between time. Okay, I can directly find the difference of these two. Okay, so like what does this means and what does this mean? Okay, so this means basically this is transition from t0 to t1. I'm going from t0 to t1, right? Transition from my state variable is going from t0 to t1 for that particular time. Transition from t1. And what does this mean? This means transition from t2 to t0, right? So like t2, I'm first at t2, then I'm going to t0, right? So this means, okay, let me write this a bit smaller actually, because I won't have space for writing third one. So write this a bit smaller. Transition from t2 to t0, right? So this time it's a different transition. And what does this transition mean? So this is the direct transition. Okay, direct transition from t1 to t2. Okay, directly from t1 to t2. So this one I won't write. This one is basically the result, right? This one is basically the result. So like again like you can do the proof, right? Again the fake proof basically. So what you can do, like with basic intuition only. So what does this become? What is 5 of t1 minus t0? It is basically equals to e raised to power a t1 minus t0, right? And what is 5 of t0 minus t2? It is equals to e raised to power a t0 minus t2, right? So this is basically all the like equations. Now if I multiply these two, right, if I multiply these two, what do I get? So 5 of t what was this, t1 minus t0 into 5 of t0 minus t2, what do I get? I get here is 5 of t1, basically this is e raised to power a t1 minus t0, and this is e raised to power a t0 minus t2. Okay, now this side the power gets cancelled, only we're left with t1 minus t2. Okay, this simple arithmetics you can do. So like yeah, this is not the actual proof, but this is how you can understand, right? This is how you can understand or remember, right? Remember, okay, t1 minus t2. This just helps you to remember the formula, okay? All these things, all these properties, to just have a quick like check in, like what was the property, else you may forget the property, right? So yeah, else like this is not a real proof, okay, don't worry. So yeah, this is e raised to power a t1 minus t2, which is defined as phi of t1 minus t2 basically, okay? So yeah, that is what the result is, that is what this property is. Now we have another property which is basically a theoretical property, right? So what is a theoretical property? The fifth property, right? What is the fifth property? It means basically state transition, like it tells us state transition process is a bilateral process, right? Bilateral, it means if I go from t0 to t, I can also come back from t to t0. We just have to change the state transition matrix, okay? So I can find the values. So like this is just a theoretical point, state transition matrix, not matrix, state transition process, right? State transition process is a bilateral bilateral process, okay, is a bilateral process. So this is basically my state transition process, what this is. So basically transition, what this means is transition in time can take in either direction, either I can go in the positive direction or in the reverse direction, just the equation will change, okay? So yeah, let me explain it to you. So x of t, right, x of t is equals to phi of t minus t naught into x of t naught, okay, x of t naught. So this is basically what my like equation I get, okay? If I go from like transition from t naught to t, okay, my equation, my state variable will be from t naught, because I am going from t naught to t, right? That's why I get x of t. Now if I go from some other variable, if I go from some other time, this x of t will also change. So this is what I was telling, that if my initial condition is on some other time, then my state transition matrix will also be on some other time, right? Or on some other time, t minus t naught, basically the equation will come like this, okay? So yeah, that was the main important like point that I wanted to get to. So let's do like the basic proof only. So what is the basic proof? What is the basic proof? So if my x of t simply is equals to phi of t into x of 0, right? So this was the standard equation, right? Now if I multiply with inverse on both sides, if I multiply with inverse on both sides and like basically pre-multiply, because this is on the like before, right? So x of 0, right? So what does phi inverse I can write? Phi inverse I can write is minus t, x of t equals to x of 0. So what does this mean? So I'm going reverse in time, right? I'm going reverse in time. So this is, I'm going reverse in time. So I can find the state variable x equals to 0 if I know the state transition matrix at t equals to minus t. So I'm going reverse in time. Okay, so this is bilateral. I can go from here to here also, or from here to here also, okay? For both ends I can go, okay? So yeah, this was the basically question, okay? This was the basically question. So like this was the proof only, okay? If you don't understand this equation, don't worry, you have to mug this up, okay? You have to mug this up, basically you have to mug this up, sorry. And here I show like try to understand you, explain it to you a bit, like try to explain it to you a bit how is it a bilateral process, okay? How is it a bilateral process? I can go from t to 0 by this equation, from t to 0 by this equation, like sorry, I'm telling it wrong. I can go from 0 to t by this equation, by phi of t. I can go from 0 to t, I can go from t to 0 by this equation, minus t, right? I am going in the reverse direction, simply in the reverse direction. That's how it is a bilateral process, okay? I'm going from 0 to t in the forward direction by phi of t. I'm going from t to 0 in the reverse direction with negative, right? With negative, so reverse in time. So I hope you understood a bit of it at least, okay? So this equation you have to mark this up, okay? This equation you have to mark this up. I'm really sorry. I don't have any option. But from here I try to explain it to you a bit how is it happening, right? How is it happening basically. So yeah, like how to prove it. Basically you combine the previous proof, right? Previous proof with this one, with x of 0 also, with t naught, and you'll get your equation, right? You will get your equation. So just, yeah, that's how you will do. Now let's solve for a question. So we have been given like a state transition equation, and this time, right, I have changed the I. Okay, this time I changed the I. So if we always solve the same way, then like you will also get bored, I will also get bored. Okay, so yeah, and also read the question and solve it by yourself. So for the state diagram, state transition matrix has been given. Note it down. Okay, now what this is asking is to find x1 0, x2 0, and x1 2 and x2 2. Okay, so like we don't have x1 0 and x2 2. We have x1 t, x2 2 at t equals to 1, right? At t equals to 1 we have these values, but we don't have x of like x1 of 0 and x2 of 0. Okay, and x1 of 2 and x2 of 2. All these things we don't have, right? So yeah, so now what we'll do, solve for the question. So what we'll use is this equation. We'll use this equation, right? Simply we know x of 1. Okay, hence I have to write phi of minus 1, and we have to find x of 0, right? X of 0. So this equation we'll use basically. And for this one, again the fourth property we can use, right? So yeah, let's first write the equations. Okay, I hope you are solving by yourself. Pause the video, solve it by yourself, then you come back to my solution. Okay, so what are the equations? Equations are x dot of t equals to ax of t. Okay, and what is x of t equals to? X of t equals to phi of t into x of 0. Okay, this was my actual equation, right? This was my actual equation. What is phi of minus t? What is phi of minus t? Phi of minus t is simply equals to x of t. Okay, like this I am using the previous property, x of t into x of 0. So here, right, here I will put t equals to 1. T equals to 1 I will put. Okay, so I will get my x of 0. X of 0 will be equals to phi of minus 1 into x of 1 basically. Okay, so this will be my x of 0. Now what is phi of t? So phi of t I can easily find, right? Phi of t I can easily find. It is like just this you have to mug it up. Okay, totally remember in your brain this phi of t. This is very important. Okay, so this is what this is equals to Laplace inverse of si minus a. Okay, of this inverse, si minus a inverse, right? So like we'll solve with Laplace only. Okay, mostly we'll solve with Laplace only, and the like time domain method that I told you, this may come in handy in some very few situations, right? So this, right, this is si minus a inverse. Okay, so what is this? So this, right, this is simply what is like si s minus 0 s the 0 minus 1, so this becomes minus 1, and again this is s this is 0 minus 2, so this becomes 2, and that is s plus 3, right? Minus 3, so this becomes s plus 3, and we have to find the inverse of this. So again, right, this becomes s plus 3 into s, okay, plus 2, and this is s 2 minus 1 s plus 3. Okay, so this is this one. So what is this? This is like I can break it down, right? I can break it down like this: s plus 1 into s plus 2. Okay, I can write it here only because this will just take extra space. Okay, yeah, this is this one, right? This is this one. Okay, so now, right, now what I'll do, now simply like finding the like Laplace inverse of this, but first let me expand this basically. So expanding this will be simple only. Okay, oh sorry, I forgot to swap this, right? I forgot to swap this. Okay, I did the opposite actually. What I did was I simply swapped the off diagonal elements. What I had to do was just swap the main diagonal elements and change the signs, right? Sorry, I'm really sorry. Okay. too much of work and I'm missing upon simple things. Okay, so yeah, just be careful, like in exam also this may come in like silly mistakes and all those things. So this may happen, right? Silly mistakes. So now, right now, I will like expand this. So this is equals to s plus 1 into s plus 2. Okay, and s plus 3 only. This is okay, this is like 1 by s plus 1 into s plus 2, and this is minus 2 by s plus 1 into s plus 2. And what is this? This is s by s plus 1 into s plus 2, right? So yeah, this is my simple matrix equation, right? Simple matrix equation. Okay, so yeah, now right now what we'll do. So I can again like do partial fraction. So if I do partial fraction, right, this becomes I put s equals to minus 1, I get 2 by this is 1 only, this is 2, so 2 by s plus 1. I put s equals to minus 2, I get minus 1 in the denominator and the 1 in the numerator, right? So minus 1, so minus 1 by s plus 2, and this is simple only. I put s minus 1, so I get 1 by s plus 1, and then again minus 2, I get minus 1 by s plus 2. Okay, and this is what is the expansion for this. So the expansion for this is I put s equals to minus 1, so I get minus 2 by s plus 1. I put s equals to minus 2, I get plus 2 by s plus 2 basically. Okay, now I put s equals to minus 1 in the last element, right? So what do I get? I get minus 1 on the numerator, and in denominator we have 1, so I get minus s plus 1, and I put s equals to minus 2, I get minus 1 in the denominator and minus 2 in the numerator, so it is plus 2 by s plus 2 basically. Okay, so what is the equation that I am getting? What is the equation that I am getting? So the equation, right, that I am getting is simply now what I'll do is take the Laplace inverse of this. So Laplace inverse okay, Laplace inverse of this. So Laplace inverse of this is 2 raised to power e minus t basically, and this is minus of e raised to power minus 2t. Okay, I will understand it. This is 1 only, this one only, because this is 2. Okay, this 2, that's why this is 1 only. And what is this? So this, right, this is e raised to power minus 1, e raised to power minus t minus e raised to power minus 2t, right? And what is this? This is my e raised to power 2t. This is like on the coefficient we have 2 also, so minus 2t minus 2 e raised to power minus t, right? E minus t. Okay, yeah, e minus t, and this is 2 e raised to power minus okay, minus 2t actually, and this is minus also, right? Minus e raised to power minus 2, minus e raised to power minus 2. Okay, so yeah, this is what my like the Laplace inverse of this is, not the Laplace inverse of this. Okay, so this was my equation. So let me just check once, am I doing something wrong? S minus 2, if I put this is minus 1 and this is 1, so yeah, I get minus 1 by s right here. Okay, so this is my equation, s equals to minus 1 if I put, so this, yeah, this is my Laplace transform. Now what I just found the state transition matrix, right? This is the state transition matrix, phi of t basically. This is the phi of t. So put just t equals to minus 1 to find phi of minus 1, right? So phi of minus 1, what will the value? So it will be 2 e raised to minus 1 minus e raised to power minus 2, okay, 2 e raised to power minus 2 minus e raised to power minus 1, okay, and this is e raised to power minus 1 minus e raised to power minus 2. Don't worry, this difficult question won't come, okay, some simple question will come. I'm solving the difficult questions for you, so that like this much calculation may not come, most probably will not come, okay. 2 raised to power minus 2 minus e raised to power minus 1, okay, e raised to minus. So like, yeah, this is my state transition matrix. Now what do I have to find? I have to find x of 0. So what was my x of 0? It was simply phi of minus 1 times x of 1, right? X of 1. So what was my x of 1? So my x of 1, right? X of 1 was x of t equals to 1 comma 2, 1, so 1 2, right? So let me copy this. One comma 2, you solve this, you get your desired answer, right? So x of 0, right? X of 0 simply will be equals to this 1 times 2, so this is e raised to power minus 1 minus 2, and this is 2, so this is basically 4 e raised to power minus 1, and this is okay, not this is 1 and this is 2, okay, fine. 1 is this, okay, and this is like 3 e raised to power minus 2, okay. This is my first value. Now what is my second value? Second is this one, right? 2 times this, 2 times this, 2 minus 2, and this is like 2 only, so these are getting added. So this is 4 and this is 2, so I am getting 6 e raised to power minus 2, and this is minus 1 minus 2, and this is minus 2 also, so this is minus 4, right? Minus 4 raised to minus 1. So you solve it like this, right? You solve it like this. You don't solve it like okay, one thing I did wrong. Okay, what I did wrong? Tell me what I did wrong. I had to put minus 1, right? So I had to put minus 1. This ones should have become plus. So yeah, these were wrong, right? So this all of these were wrong. So this is how your silly mistakes happen, right? So that's how you eliminate your silly mistakes. Just practicing more and more questions, right? So yeah, this will be plus only, 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 this will be plus, okay. So yeah, these things you have to keep in mind, really, okay. So yeah, I know a few of you are screaming like, what are you doing, why, like, you put the wrong powers, okay. So yeah, you now what you do, now you put the value of exponentials, right, and solve for the question, right? Now you put the value of exponential and solve for the question. So this is how you should do it, basically, okay. So yeah, I want to write the expressions here, okay. You write it for yourself, like the answer is not that important, like this one is the answer only, just put the value of exponential and you'll get your answer. So what will be my okay, I don't have space. What will be my second part of this question? The second part, right, it asked to find x of 2, right? X of 2 it is asking us to find. So what will be x of t equals to 2? T equals to, either we can go from t naught, right? Either we can go from x of 0, we know x of 0, we can substitute the phi of t directly from there, or what we can do is use the fourth property. What does the like the fourth property, the fifth property, basically what does the fifth property tell us? Basically, right, sorry for the whatever burp, okay. So x of t will be simply equals to phi of t minus t naught into x of t naught, right? X of t naught. So this is the like the fifth property. So again, you replace t equals to 2 here. T equals 2 here. What do we get? We get phi of 2 minus t naught, right? 2 minus t naught is t naught in our case is 1 only, because we know x of 1. We know x of 1. We can solve from x of 0 also, because we just found out. But if you want to directly solve, right, if x of 1 is given and from x of 1 you want to find x of 2, this is how you solve. This is how you solve, right? You use the fifth property. So this is, you need to mug this up, okay. So this is x of 1, okay. Now what do I get? X of 2 will be equals to simply phi of t, I know, Okay, I will replace phi of t equals to 1, right? I will replace phi of t equals to 1. So yeah, let me copy this matrix again. Phi of t equals to 1, let me copy. This is phi of t only. Okay, equals to phi of 1 x of 1, right? So what will be my phi of 1? So my phi of 1, right, it will be 2 raised to power minus e raised to power minus 1, okay, minus e raised to power minus 2, 2 e raised to power minus 2, minus 2 e raised to power minus 1, 2 e raised to power minus 2, minus e raised to power minus 1. Okay, so this is my phi of 1 basically. So yeah, now like we can easily like solve this, right? And again, like put what is x of 1. X of 1 was 1 comma 2, right? 1 comma 2. So again I put in the equation this x of 2 I need to find, and I got the phi of 1. Okay, got the phi of 1. Now just replace x of 1 multiply with x of 1. So this is 1 comma 2. Okay, so again, right, we solve this, right? So this is simply again 2 times this 2 also, so this becomes 4 e raised to power minus 1, and this is minus 1 times minus 2, so this becomes minus 3 e raised to power minus 2, right? And this one becomes 2 times 1, and this one becomes minus 2 times 2, so this one becomes so okay, this is only like, okay, am I doing, yeah, 4 plus 2, this is 6 e raised to power minus 1, and this one, right, minus 2 times 1, and this is minus 1 times 2, so this one is minus 4 e raised to power, just the like the powers have changed this time. Okay, e raised to power minus yeah, okay, I made some mistake. This is e raised to power minus 2 actually, and this is e raised to power minus 1 actually, 1, and this is okay. Okay, this is my basically matrix, right? This is my basically matrix. Okay, so yeah, this is the solution of the question. I will not put the value of exponential, you will put it. That's the homework for you. Okay, so yeah, I will solve this, and you got to the same exact answer here. Okay, so yeah, now let's do the next thing, that is the complete solution of state space equation. The complete solution of the state space equation. So what will be the complete solution? So the complete solution, right, what were my equations? My equations were like this, right? Ax plus bu, then the other equation is cx plus du, right? This was my other equation. Now what I will do, I will do it for the case 2, right? I will do it for the case 2 when input is not equal to 0. When input is not equal to 0, then and the like the state initial values are also not equal to 0. Case 2. Input is not equal to 0. Okay, if input is not equal to 0, what we will do? So basically u is not equal to 0, and like my x of 0 is also not equal to 0. Okay, so there x of 0 was 0, but what was the different, like in the previous case, right? Different was there was some initial condition, but it was not present at x of 0, it was present at some other point. Okay, so due to that initial condition, there will be some x of 0, right? There will be some x of 0. Okay, there will be some x of 0, but we don't know the x of 0. They haven't told us x of 0, right? So you might say, yeah, the x of 0 is 0. Okay, in the previous question the x of 0 is 0, like why? Then what is the significance? No, the state variable has some initial value, but they haven't told us that it is at t equals 0. It is at t equals to 1. Okay, we have to find the x of 0, and from there you can also solve this equation, right? Like without the input that I'm talking about in the first case, right? So yeah, like that is the important point to note here. X of 0 is not 0 in the previous case, as you saw, right? X of 0 was not 0. Okay, here, right, x of 0 was not 0, it was some finite value. Okay, so that's why you understand, right? So yeah, this won't be 0. this won't be 0 for the previous question. Okay, I have that doubt like cleared from your head, right? Cleared from your head. If we have been given initial condition at t equals to 0, there will be some potential, not potential, there will be some value of x of 0. Okay, it won't be 0. It won't be 0. Okay, that is the important thing to note, because we are doing the natural response, right? Due to the natural response, there will be some value. Okay, the source is not there, but there will be some value in the state variables, right? So that's why. So what is the case 2? What is the case 2? What is the case 2? So case 2, right? Case 2, input is not equal to 0. So my equation, I have to solve it like this only. Ax plus bu. What I will do, I will take the Laplace transform of this. I will take the Laplace transform of this. So what will my Laplace transform become? So Laplace transform, right? It will become s into xs minus x of 0 equals to a into xs plus b u of s, right? So again, taking in common few things. So if I take like this s I minus a, this is a matrix format, into x of s, which is equals to x of 0 plus b times u of s, right? B times u of s. So again, I will take the Laplace, like not Laplace, I will take the inverse of this. Okay, I will multiply with inverse. So this will become x of s, and I will like pre-multiply inverse basically. So this is si minus a inverse times x of 0 plus this is what? This is like b is in the after, right? B is after. So this is si minus a inverse bu of s. Okay, this is important. Like b is after this, so I'm pre-multiplying, right? So my si minus a inverse will come before b, right? Before b. So what will be basically my x of s equals to? So right, I can write this si minus a inverse in Laplace domain only. Okay, and the matrix what I will write here is like phi of s. Matrix what I will write is phi of s into x of 0. Okay, and this one also I will write phi of s plus b u of s. Okay, not plus, multiplied by p u of s. Now what does this represent for my state, like state, right? So right, this represents my 0 state response, and this represents my 0 this represents my 0 input response, and this represents my 0 state response. Okay, this is not a response actually. We have to multiply c with this also. From there we will get the response. Okay, but just food for thought, this will represent like my 0 input response, and this will represent my 0 state response, right? Because this is not the response, y of s is the response, but still, like, food for thought, this is the main thing, right? I will put the value of x of s in the equation c, like c times this one will be y of s only, because d right, d is most of the case, in the most of the cases is equals to 0. Okay, d in the most of the cases is equals to 0. So in the y of s I will put c times this, so this is my, like, the responses, right? So what do I call the phi of s, right? This is known as the phi of s. What do I call it? I call it as resolvent matrix. Like, same thing only, just it is the Laplace transform of the state transition matrix, right? So phi of s, right? Don't need to think about this much, but this is just a terminology, and we have to like learn all these things and know all these things, right? So phi of s is equals to resolvent matrix, right? Phi of s is equals to resolvent matrix. Okay, so now what is my like, basically how do I write it? So this, right, I write the equation like this one only. Write the equation like this one in terms of resolvent matrix. So let me write in terms of, like, matrix format, so that will be much more easier for you. Okay, and like I will, like, the formula you need to remember is this one. Okay, obviously we will not solve, we will take the Laplace inverse of this, and from there we will solve. Okay, we'll take the Laplace inverse of this, and from there we will solve. So if I do the matrix multiplications here also, you will understand like are my equations correct or not. Okay, so this matrix, right, what is this matrix? So this matrix is basically order of n cross n, right, n cross n. Okay, this is the that like transition matrix, right? This the order of resolver matrix will be n cross n. Okay, the order of resolver matrix will be same as the order of A, right, because it was simply the eigen number of eigenvalues, all those things, e raised to over 80 number of eigenvalues, if you remember. So yeah, now what is the order of x of 0? X of 0 is n cross 1, right? It is a column vector, and it, the number of rows is like number of state variables. Okay, and what is the state space vector? State space vector is basically this one is basically again n cross n, but what is the order of B this time? If you remember, right, try to say what is the order of B. Say what is the order of B. Like I hope you remember it. So the order of B was n cross m. N was the number of state variables and m was the number of inputs. What is the order of U? It was m cross 1 only, right? M cross 1 only. Okay, so like if you even forget, right, so this you have to remember, like this one you have to remember that yeah, this one order will be always n cross n. Now you go to here. Now what, how to remember the number of columns of this one, right, the previous matrix, and the number of rows, this should be same, right? For us to do the proper matrix multiplication, we can't do the proper matrix multiplication if the number of columns and the number of rows aren't same. So they cancel out and we're left with n cross m. For this case also, the number of columns and number of rows should be same for us to do proper matrix multiplication. So this becomes n cross 1. Okay, and this becomes, after finally it becomes n cross 1 only. So yeah, so what is the order of the state space variable? It is n cross 1 only, right? N cross 1 only. So yeah, our equation matches. Okay, so that was the basic like thing to note here is that. So let me expand this also. From here you will understand. So x of s, right, let me write this in different color. We don't need to waste much time, but just to understand the basic orders and all those things. So this also come in handy in exams sometimes. Okay, so these tricks, short things come in handy in exams. So yeah, this whole thing, right, 5s times x of 0 becomes n cross 1 plus this 5s b times u of s becomes n cross 1, right? So yeah, that's how we match the order. That's how we match the order. Okay, so yeah, this is what my x of s is. Now let us do the Laplace inverse. Let us do the Laplace inverse. So what is my Laplace inverse? It is x of t equals to, so this Laplace inverse of this one will be x of t only. Okay, let me write this in matrix format only. Okay, n cross 1. And what will be the Laplace inverse of this one? So this one, right, this one is only a constant scalar value. So this Laplace inverse of this one will be phi of t. We already know it is state transition matrix, already know this. So phi of t into x of 0 basically, and this is n cross 1. Okay, this is n cross 1 plus, right, plus what is this? Again the Laplace inverse of this is phi of s, and this is like just a scalar value only, and like Laplace inverse is not that easy. Okay, find the Laplace inverse of not that easy, because this is in the middle. Okay, this was in the outside, so finding the Laplace inverse is easy for this one. Okay, but finding the Laplace inverse is not that easy for this one. Why? Because this is in the middle and we're multiplying two s terms, right? X, let's say I have one signal x1 and x2. Okay, I'm multiplying them. So what will the outcome become? It will be convolution, right? It will be convolution in time domain if multiplication in Laplace domain. As this was just a scalar, I can just take this out and find the Laplace inverse of this one, because this was just a single term, right? Single x1 of t, let's say x1 of s, let's say. But here we have x1 of s and x2 of s, so we have to do convolution also. So doing convolution will be very difficult. So what we will do, I will just solve in Laplace domain. I will solve this matrix in Laplace domain, then take the Laplace inverse. I will solve this whole matrix, then take the Laplace inverse. Okay, that's what your procedure should be. So this one, right, take the Laplace inverse of this whole matrix, phi of s b u of s. Okay, this is n cross 1. Okay, okay, so this is multiplication in frequency domain will be equivalent to convolution in time domain. So what is the thing that we do? We just keep it as it is, solve this matrix, then finally we get some matrix in terms of S. From there I will take the Laplace inverse, right? So that is the important point to note here is I will not take the Laplace inverse directly before solving, right? First I will solve this matrix, then only I will take the Laplace inverse. So yeah, that was the important point that I wanted to say to you, right, in this particular equation. So I will take the Laplace inverse after equating, right? After equating, else like you can solve this also. So if I solve this, right, if I take the Laplace inverse in multiplication format only, so how will I solve it? So solving this will be difficult. So what I will do is simply delete this. Okay, this will be simply phi of s, not phi of s, phi of t convolution of b u of t, right? Okay, b is a scalar, but other things are there, right? Other s terms are there. So again, if I expand this, n cross 1. So how I can write this? This is e raised to power 80 only, right? Times x of 0. Okay, and this is only n cross 1. Okay, and what does this become? This is also e raised to power 80 convolution of b u of t. Now how to write convolution, right, in terms of integration? Okay, I know how how to write convolution in terms of integration. So again, x of t equals to e raised to power 80 x of 0 n cross 1. Now we have x1 convolution of x2, right? So what I will do is do the integration from t equals to 0 to okay, tau equals to 0 to t, and this is what x2 of tau. Basically this will t will be changed into tau, so this will be tau only times e raised to power a times t minus tau. Okay, so yeah, that's how we do the convolution. So this is d tau, this is d tau, right? This is d tau. Okay, so yeah, this is what my x of t will look like. Okay, so yeah, now what will be my y of t equals to? So my y of t, right, it will be I won't write the time domain expression. Okay, I won't write the time domain expression. I will write the Laplace domain expression. So from there you can derive the time domain. Okay, let me write the y of t here only. Okay, so what will be my y of s? Y of s will be simply c x of s plus d u of s, right? So again, y of s equals to cx of s, right? So cx of s, so cx of s is this one, right? X of s is only this one, so I can directly write it here in Laplace domain only. So I will write a time domain. I will write it like this one. Okay, so c times phi of s into x of 0 plus phi of s into b into u of s, right, plus d u of s. So what I can write, y of s equals to, this is c phi of s x of 0 plus what I will do, I will take the u of s as common, so this becomes phi of s times b plus d. We have c also at the outside, right? C also at the outside. Okay, and we have u of s at the end. ufs at the end. Okay, so write this, right? So what is this equals to? This is the force response and this is the natural response. So from here also you can understand, and this c phi of s times b plus d equals to the transfer function, right? Yeah, this we'll study in the next few lectures. So now here I can write this is the zero input response and this is the zero state response. Okay, so from here I can write all these things. Okay, so yeah, like this is the equation in the Laplace domain for y of s. This is the, you have to remove, and this, right, this term is the transfer function. We will study this in the next few lectures. From there you will understand. So yeah, in the time domain, how can I write? So y of t, right, I'll just replace y of t like this. Y of t I can directly write that is this one only, right, this one only. So in time domain, y of t will be e raised to power at x of 0 plus I will have like a c term at the outside. So c e raised to power at b. Okay, now this b isn't just simple b, right, it is convolution. So convolution with u of t. Okay, this is also c, sorry, I forgot a c over here, plus d u of t. Okay, I can't just simply take common here. Okay, can't simply take common. So this response again, right, this response will be, okay, am I doing something wrong here? Okay, the wrong thing is this is only c times this one, right? C is not times this one. Yeah, that was the wrong thing. So just be careful. Okay, just be careful with this one. So yeah, c times this one only. Okay, and this is d is separate. Okay, d is separate. So d was separate only. C was multiplied with this one only, right? So yeah, sometimes mistakes happen. So in this case, what are you getting? D is separate, right? So this response is the zero input response and this response is the zero state response. Okay, so we have all learned all this. So let me summarize everything in a table. What do I get? So summary, right? We'll also study all this further, the equation. We'll do questions on that, so from there you will also understand. So let me make a table for you. Table, right? The input is basically u, right? We have x of 0 and we have solution also. Okay, now, right, this is the initial condition and this is the input, right? So if my input is equals to 0, okay, let me write this in different color. Input is equals to 0 and my initial condition is not equals to 0, then what is the response? What is the solution? Solution is zero input response, right, which is basically force response, sorry, which is natural response. And what happens in the differential equation? We're only left with the complementary functions. If we ever solve the differential equations, right, multi-order differential equations, second order differential equations, all those things, so there we used to get two solutions. One was a complementary factor and another was a particular integral, right? So this will be zero input response will be my complementary solution, complementary factor basically. So in this we make the input as 0 and solve the differential equation due to initial conditions. And now when the input is not equals to 0 and our initial condition is 0, then it becomes zero state response, and this is the particular integral solution of the, okay, solution, I just I should have said here, solution of the differential equation, right? So let me reduce this. Solution of differential equation. So this is just for basic knowledge only. Okay, don't need to put too much stress on this now, right? Now if this is also not equal to 0, this is also not equal to 0, then what I will get? I will get both responses. I will get zero input response plus zero state response. That is what we just did. We found out the complete solution, right, with both of them non-zero. Okay, and if both of them are equal to 0, then what is the point? Solution doesn't exist. There isn't any solution, right? So in this case, solution doesn't exist. Okay, solution doesn't exist, right? Solution doesn't exist. So yeah, this was basically it for this lecture. So mainly what we studied. So first we learned the properties of state transition matrix. So let me give you a quick recap of what we studied today. So we learned the properties. So how do I solve for this equation, right? How do I solve for this equation if x of 0 is not given, if x of 1 is given? Okay, then we will find the x of 0. From there we will solve either or we can directly solve from x of 1 to any x of t, right? So that's how that's why we needed the help of properties of the state transition matrix. So yeah, the first property was simple only. X of 0 will be identity matrix. Then like not x of 0, phi of 0 will be identity matrix. Then phi dash of 0 will be our A matrix only, system matrix only. I gave you a fake proof, basically just the intuition to like keep in your head, like whatever things you remember, right? Next is phi of kt. So phi of kt is because phi raised to power kt is phi of kt. Again I gave you a fake proof. Okay, so yeah, this was the transition proof, right? If I am going from t1 to t0 and t0 to t2, then what will be my final result? I don't have to multiply these two individually, I can directly find this one, right? Okay, so yeah, all these are basic properties. Okay, this one is the most important, you have to remember this. Okay, mark this up. I proved you like this is a bilateral process. State process is a bilateral process, state transition process, because I can go from x of 0 to x of t, and I can go from x of t to x of 0. Why is it a bilateral process? If you see, like if there is some initial condition applied, right, at t equals 0, then this will forever be in the circuit, right? Let's say I have 2 volt applied at the capacitor, right? It will forever be in the circuit. Okay, now let's say I have like initial condition of 2 volt in the capacitor. Now at t equals to 1, that 2 volts becomes 1 volt, right? RC circuit, 2 volts becomes 1 volts. Now, but the question has given us that one second condition, like 1 volt condition. Okay, it hasn't told us that we have 2 volts, right? 2 volts at x of t equals 0. So what we can do, we know at t equals to 1 we had 1 volts. So from there we can find, right? From there we can find that what was the value at x of 0, t equals to 0, right? So yeah, that's why it's a bilateral process. From x of 0 I can go to x of 1, from x of 1 I can go to x of 0. That's why this is a bilateral process. Okay, so yeah, again we solved few questions. Okay, these were easy only. Okay, now then we did the complete solution of the state space equation, right? Complete solution basically. So yeah, from here we solved the complete solution. Yeah, this was the basic summary. Okay, so when the input is also not equal to 0, and we don't, just one thing to keep in mind here is this one, right? This one. So we don't take the Laplace inverse of this one, we take the Laplace inverse after solving this equation. Okay, after solving this equation, or when we solve the questions, from there you will understand, right? So always do the matrix operation first, then take the Laplace inverse. That's how it is easier. If I take the Laplace inverse first, then I have to do convolution, which is very hectic, right? Very hectic. So I don't want to do that. Okay, so yeah, that was the main thing in the second part of this lecture, right? So yeah, thank you for watching, and in the next lecture I will see you again.